All are having same mass. Himself is telling initially 5 balls of equal mass. Assume that all balls undergo perfect elastic collision. Find the velocity of ball C when no more collision between the balls can occur. Okay, now draw the diagram. Don't make a guess. You must draw the diagrams. You have to follow the sequence. What sequence will go on here? Now first, wall will collide. A and B will collide. First, A and B will collide. So let's get into the sequence. So this is the initial. Next step will be let's see now. The first after impact, this is A, B, C, D, E. After impact, they'll exchange, A and B will exchange velocity. So this will move with 8 meter per second. This will move with 9 meter per second. Now D and D will collide. So they'll exchange velocity. C will continue to move with 10 meter per second. So this will be 7 meter per second. This will be 11 meter per second. Now A will continue to move away. Now 9 and 10, I think B cannot collide with C and D cannot collide. So B will continue to move with 9 meter per second. Now C and D will collide here. So they'll exchange their velocities. So this will be 7 meter per second, 10 meter per second, and this will be 11 meter per second. 10 meter and 11 meter. So therefore D and D cannot collide. What is the next situation? So this will be as it is, 10 meter per second, 11 meter per second. So this will be 8. Of course, A will move away. The diagram, I don't have space. I'm just showing there only. Now B and C will collide, no? And they'll exchange velocities. 7 meter per second. And this is 9 meter per second. Is it possible further collisions? Not possible, no? He's asking find the final velocity of balls when no more collision occurs between the balls can occur. So there's a final, no? So what is the velocity of C, no? Will be 9 meter per second. I think these are the types of questions what you can expect in advance. Within that time, 2 or 3 minutes, you're supposed to crack this. So don't go for any formula. All are having same mass and elastic collision. Exchange of velocities occur. This idea. Similarly, I'll give one more. Just try to say, I think this everyone can do, no? Nothing big, all these problems of like this, especially collision chapter. When it comes the final exam, no, there is no something like a, you must have just basic ideas, elastic, inelastic, and oblique collision. So nobody will ask you in depth about any questions what we are going to discuss. Now let me test with your basics. This is a ball which is move with a 2 velocity, and there are some balls connected. All are identical. 1, 2, 3, 4, 5, 6. This is a body. And let E equal to 1, and all these are 1, 2, 3, 4, 5, 6 are at rest. Now tell me, after collision, they'll exchange velocities, no? It's over. After collisions, what happens? The objects will exchange their velocities. Exchange of velocity, I think velocity means what happened? What velocity the C was moving after collision, what happened? The D will move with that velocity. And before collision, what was the velocity of that should be the velocity of C. Now, tell me what will happen here. Now, there are two ways are there. So one student, what happened, will give answer like this. The another student will give answer. Then who is right, who is wrong? Means it's not something. Physics, lot of diagrams are there, huh? Not plain writing. This is this 6. Okay, one student will interpret like this. The other student, what you'll do is, and both will have tell me oh, what happened here? Only 5 are there, no balls? No, 6 are there. 6 balls are there. Okay, now who is right, who is wrong? Situation 1. Let's apply conservation of momentum. What is the initial momentum? 2 mv. Final momentum? 2 mv. And look at here also. And after collision, what happen? All these are at rest and they will come to rest. Because the elastic collision, no, E equal to 1 and all are having same masses. Look at this pairs. Tell me situation 1 or 2, which is correct here. Let's apply conservation of linear momentum. So not only linear momentum, look at the kinetic energy. What is the kinetic energy of system? What is the initial kinetic energy here? mt 2v whole square 2mv square. Let's calculate final kinetic energy in the second case. What is the kinetic energy in the second case? m 2v whole square by 2 2mv square. What is the kinetic energy in the second case? m plus mv square by 2. And it's elastic collision. In elastic collision, what should happen to kinetic energy? Should be equal to initial kinetic energy. Kinetic energy should be conserved. So what we have is K1 is equal to Ki. And what about here? K2 less than Ki. And moreover, it's elastic collision. No? So this is not possible. So therefore, this is correct. This is wrong. So when you are checking like which collision is possible, just linear momentum, is it sufficient? Look at initial momentum, 2 mv. Final momentum also 2 mv. Momentum is conserved. But what happened? To check whether the given assumption what you made situation, which one is right or wrong, whose help you have to take it? You should also take help of the kinetic energy. Because in elastic collision, what happened? Kinetic energy is conserved. These are all basics which you are going to take help in the application problems. I'm telling this one. You should cross